to AP Biology Teaching Tips. I'm Joy Killow. This is tip number 5, onion osmosis using image J. The activity presented here fits within AP Biology investigation number 4 on diffusion and osmosis. In this lab, students learn to calculate water potential using dynamic homeostasis. Traditionally, students use plant materials like carrots or potato cores placed in different molarity solutions, things that are large and easily handled for massing. This slant on the activity lets students consider osmotic changes they can see at the cellular level. Here are the materials you need to assemble for this lab. For the plant material, you need red onion. These cells are pigmented, making a stain unnecessary while giving crisp divisions between the individual onion cells. Image J is the program we will use to collect data on the cell changes as a result of osmosis after subjecting the cells to a 15% salt solution. Image J is a free program available from nih.gov. The students must know the field of view of the microscope they are using. This is an activity I like to do with my pre-AP biology, but I post these instructions in the room for all as a reminder at the least. Place a clear ruler on the microscope stage and focus under the lowest magnification. You should be able to see the 1 millimeter divisions on the ruler. Considering that 1 millimeter equals 1,000 micrometers, you can measure your field of view. In this picture, the distance across the center of the field of view is 4,500 micrometers. You can't easily see the ruler under higher powers, but you can use mathematics to calculate the field of view using your low power measurement. Divide the first objective by the new objective and multiply this value by the measured field of view when using the first objective. This chart shows the relationship between several lenses using a specific microscope. All microscopes are not alike. With this information, you are ready to use image J to investigate osmosis in the red onion. Using the red onion, cut a small piece of pigmented tissue. I like to provide these pieces to students by dicing the onion in advance. Using forceps, you peel off the outer layer of the onion piece. The outer layer is the pigmented layer. Make a wet mount of your onion tissue with a drop of water. With a paper towel on one side, add the 15% salt solution on the other. The paper towel will draw the salt water through. This is amazing and fast. Warn students to be ready. They will see the plasmolysis of the cell membrane in real time. When the changes stop, take a picture of the cell through the microscope. You can use your cell phone with a steady hand or a point-and-shoot camera where the lens snugs down into the eyepiece. It's a good idea to have a few backup photos preloaded for the class to access. Open Image J. The program is a bit deceptive. All that opens is the toolbar at the top of your screen. Using File, Open, find your photo. You can use Image J to measure the perimeter and area of the cell membrane before and after the saltwater treatment caused osmosis. It's fun to see the students' aha moment as they figure out how to get the before cell picture. I love their smiles when they realize the lab design gives a built-in before in the outline of the cell wall. With your picture file open, there is a little setup to do. Select the straight line tool and drag across the center of the field of view. Under Analyze, choose Set Scale. Pixels should automatically populate. You need to give it the distance that corresponds to these pixels. You know this distance. You just calculated it and measured it using the ruler under the microscope. It's easiest to convert these to millimeters because you need to add the units as well. To get a value, go under Analyze, then Measure. To fine-tune what shows up when you measure, go to Analyze, Set Measurement. I like to unclick everything but area and perimeter for this activity. Now you're ready to collect the area and perimeter of the cell membrane before and after the osmotic event, like in the example. Of course, you could process this data in a similar manner to any water potential lab by calculating percent change in area. No method is perfect. What are the shortcomings of this method compared to using something like potato cores? For one thing, we're using area, not volume. So while the trend should hold, the data will be different. This activity provides a jumping-off point for student inquiry. It also adds a tool to both teacher and student toolbox. ImageJ can make measurements on any picture, making it useful for a variety of data collecting needs. I hope you give it a try. Until next time, these have been today's AP Biology teaching tips.